Morning. So I am not what I was advertised. I'm not an interesting speaker. I don't tell jokes. I think the worst experience I ever had in my life was the time that I was on the same platform with Bruce Jenner. I know he has a different name now. But I was nervous, and I got up and I wrote a presentation out and read it. And he followed me, and he said, "I cannot believe that you read that presentation. I can't read. I have to do everything by memory." And so he got up. He has dyslexia. He got up and he just told many wonderful stories. He was fascinating. He was a lot more interesting than I am. And so, unfortunately, Caitlin is not here today, and you're just going to have to endure about an hour and a half of science, because that is what I'm about, and I'm very serious about the idea that science should influence decision-making in education. It's really, at this point, a mission for me. I've been working in this area really pretty much since Public Law 94-142 was passed, and I have strong opinions, and I get to share them with you today. This is the fifth presentation that I've been asked to give to a large stakeholder group on dyslexia in the past 3 months. I don't know why there's so much interest in it. Before then, for the last 2 or 3 years, if I was invited to do a talk like this, it would be about how to identify learning disabilities in the context of a response to intervention model. I must have done 20 different presentations talking about what eligibility would look like and how to test kids and things of that sort. And I know a lot about testing kids. I am a clinical neuropsychologist. I don't believe in testing kids with dyslexia a lot, and we'll talk about that. But these are some things that we know. The first is that dyslexia is real. A lot of times when I talk, people think that I'm disputing the existence of dyslexia. I am not. I absolutely believe in it. I think the problem and what confuses people is that people with dyslexia often have other problems. They might have attention deficit disorder, they might have problems with math or written expression, and certainly dyslexia is not the only type of reading disability. Some kids have comprehension problems, for example, where basic skills are not really an issue, and that confuses people quite a bit. Dyslexia itself is a very definable disorder. It has very specific cognitive correlates, and they predict. There were lots of questions that I saw about how do you screen for dyslexia. It's not difficult. We've had this technology for over 25 years now. You administer very brief assessments of letter sounds and naming, phonological awareness. In kindergarten and grade 1, by grade 2, your screening is read words. Read a list of words. If you don't read at a certain level, that's a problem. It's even better if you time it. But these screening assessments need to be very brief because you want to screen every child. And when you screen, people start worrying about false positives, that kids are not going to get identified who don't really have problems. Well, actually, false negatives are a bigger problem, because what you don't want to miss kids that need help. And if you're in a progress monitoring system and the consequence of screening is to put kids under surveillance, a false negative error is far more serious than a false positive area. Screening and progress monitoring are not diagnostic by any means. Many children identified with dyslexia can be taught to read if they're at risk, if you emphasize early identification and explicit, comprehensive, and differentiated reading instruction. That's very important. I did not read the Colorado Read Act. I don't have any intention of aligning my presentation with legislation. That's a chronically frustrating experience. But what I am talking about is what I know from science. The problem is that remediation of dyslexia from 3rd grade on is a very difficult, very expensive process. It requires high intensity and, again, a comprehensive, differentiated approach to reading instruction, but it is much more expensive to remediate dyslexia than it is to try and prevent it, and you won't be successful in preventing every case. And then the other thing that we know is that we know a lot about what happens within the brain and about the heredity of dyslexia. And I see my colleague, my fellow neuropsychologist, Ruth Pennington, working back there. Colorado has a learning disability research center that's like the one that I direct. And what they do more than anything else is study the heredity of reading disabilities. So Bruce can correct me when I misstate some of these findings today. Here are things that we don't know. We do not know how many people have dyslexia. And in a sense, it's a meaningless sort of conversation because basically we should be less worried about who has dyslexia and more concerned about who can't read, who doesn't have basic reading skills. The label is not that important except that it does provide guidance, particularly in terms of understanding the research. If you want to know how many people have dyslexia, basically the correct answer to the question is how many would you like? Because it's always relative to where you put the threshold. And I'll explain that a little bit more in a bit. What we don't know is how to scale effective identification and intervention and translate what's known from science. Some people think Reading First was a failure. That was the federal government's most significant effort to scale educational science into research. It is not true. It was not unsuccessful. If you look at state-level data, it was effective in many states. Early reading intervention is effective to a point where people like me and Bruce cannot even get funding to study it anymore. The issues are all about how to scale it and get it into practice. We do not know the level of intensity that's required to remediate a person who is diagnosed with dyslexia, where early intervention has not worked. We have a lot of work to do there. We don't know how to use the research on brain function and heredity to identify and intervene with learning disabilities. It helps us understand what to do. It gives us a comprehensive framework for understanding people with dyslexia, but it hasn't led to things like brain or genetic tests, and in particular, although it clarifies what we should be doing for intervention, there's no such thing as like brain-based intervention that doesn't involve reading. In fact, teachers do it every day when they teach kids to read. Reading is a brain-based intervention. And we don't know how to get policymakers to stay the course and follow science as the basis for decision-making in education and child development. You know, the pendulum swings, something else becomes faddish. That's the problem. There are a lot of misunderstandings about dyslexia. There are misunderstandings about the definition and the prevalence, the role of IQ, the specificity of dyslexia, what it means to have a specific learning disability, effective interventions, what works, what doesn't work, methods of service delivery, are the kinds of service delivery models that we've used historically, which are test and treat models. We refer a kid, we diagnose them, we put them in a remedial program. Are these effective ways to deliver services? And there are a lot of misunderstandings about what it means to talk about brain structure and function. So I'm going to try and tell you some of the things that I understand specifically about dyslexia and this form of reading disability and try and clarify some of these issues. First of all, it is the most common and the best understood form of learning disability. It is a word-level reading disability. And for a while, I started calling it a word-level reading disability just because people were using the term dyslexia in so many different ways that I was afraid it was becoming meaningless. But I've sort of reverted back to the IDA definition, which I'll show you in a minute. It is the largest group of students in special education. Approximately 2 out of every 5 kids in special education are served because of a reading problem. 80% of those kids have a problem with basic reading skills. They can't decode and spell words. So it is the largest single group of kids in special education. Lots of kids who don't get identified for special education, particularly those who get shunted to, say, a Title I program or something like that, also have word-level reading problems. And that's important because the interventions that work with people that we identify with dyslexia also work with other groups that have word-level reading problems. It's addressed in IDEA, even though IDEA doesn't really talk about dyslexia specifically. It has a category called basic reading skills, and that is what dyslexia represents, and it's often addressed through 504 programs. but it cannot be effectively addressed solely by special education or as a problem that needs to be remediated. It's too complex and it's too developmental for that. I like this definition of learning disability. Bruce Pennington and I were part of a group that helped put it together. It says that dyslexia is a specific learning disability that is neurological in origin, which means that there is a brain basis for reading and for reading disability. It is characterized by difficulties with accurate and/or fluent. In other words, if you look across languages, in English, kids are inaccurate. In German, they're slow, but it occurs at the word level. And it's usually accompanied by poor spelling abilities. So there's a problem that occurs at the level of the single word. People have used terms like word blindness to describe it. These difficulties typically result from a deficit in the phonological component of language. Now, I said phonological, but remember, there are lots of ways that you can manifest a phonological problem and lots of pathways to what we call phonological awareness. That is often unexpected, and that's important because the key component of any definition of a learning disability is the idea that underachievement is not expected. In relation to other cognitive abilities, because lots of people with dyslexia are really good at problem solving or good at math, and the provision of effective classroom instruction. That is probably the most important, because if a child does not receive the instruction that they need when they are young, they will not develop the neural systems that they need to mediate reading, and they will look like they have dyslexia because it doesn't occur in isolation. Secondary consequences are problems in reading comprehension and reduced reading experience that can impede the growth of vocabulary and background knowledge. A group with the International Dyslexia Association recently talked a lot about whether this definition needed to be reconsidered. There were about 30 of us, and the group concluded that there was no compelling reason to change the definition of dyslexia. The definition remains meaningful for research and for practice. It includes inclusionary criteria, which means that you have to have this word-level problem with reading and spelling. It does not specify operational criteria, which is impossible, and that's because if we say that a person has dyslexia because they read where? Below the 15th percentile, below the 10th percentile, we don't really know where to set those criteria, except that we know that kids are at risk if they read below the 20th percentile. There should be no equating of dyslexia as a diagnosis and eligibility for special education because there must be a demonstration of educational need. Lots of people with dyslexia can be served in the context of general education if the general education programs are appropriately constituted and they start early. A diagnosis of dyslexia does not mandate eligibility for special education services. Depending on severity, a student with dyslexia may be appropriately served in general education or may require special education services. And that's because general education should not be left off the hook. They are just as responsible for people with dyslexia as special education programs are, and any effective intervention starts in the general education curriculum. So this is sort of a schematic of the 2002 definition. It doesn't show anything above the deficit in the phonological component of language, which has to do with the brain. It has to do with genes. It also can have to do with things that impede the development of phonological processing, like oral language disorders or gluey ears or lots of other things like that. But it leads to problems with decoding, spelling, accuracy, and fluency that interfere with comprehension because you can't access print. You're deprived of reading experience. That leads to problems with vocabulary and background knowledge that compound the comprehension problem. So it's very much a bottleneck theory. I got questions about the DSM-5 criteria. I'll show them to you really quickly. DSM-5, which is the American Psychiatric Association diagnostic criteria, is irrelevant to schools. Schools look at ESEA and IDEA, but elsewhere they look at the DSM-5 criteria. It talks about the need to show persistent difficulties in learning and using academic skills, that affected skills are substantially and quantifiably below age and significantly inferior with major life activities relative to the average person. That means that there has to be a demonstration of educational need, that it has to interfere with adaptation. And in the early versions, which a lot of us objected to, they actually put in thresholds and basically said that the person had to be below, I believe it was the 7th percentile or something like that. And we objected to that because the threshold is not as important as the need of the child and the educational system that they're working in. It says that the onset is in the early school years, although may become more fully expressed as child progresses through elementary school. It specifically notes that learning difficulties persist. And this idea of persistence or intractability is one that I'm going to return to, despite the provision of targeted classroom instruction. It has exclusionary criteria, just like IDEA does. It says that the learning disability is not better accounted for by an intellectual disability, global developmental delay, sensory disorders, other mental neurological disorders, psychosocial adversity, and inadequate education. How you assess some of these beats me, but they're there. And then I apologize for the really small print, but it goes in and it has a general category, and then you apply a descriptive category. And the only one, it allows you to describe things like word reading accuracy, fluency, and reading comprehension, reading, written expression, mathematics. But it has one called word reading accuracy. And it means specifically, and says so, dyslexia. And then I said a disorder at the level of the single word that reflects accuracy and fluency of decoding and encoding, which is spelling. But it has language specifically about that, but doesn't identify dyslexia. So what is dyslexia? It is, like I said, a problem that occurs at the level of the single word and involves the ability to decode and spell reading problems. It leads to a problem reading text, stories, essays, things like that, but it is not a text-level disability per se. That's different. It is a word-level disability. Anytime we talk about a disability, any disability that we talk about has a biological and a social reality that varies with the disorder and the person. It is not coincidental that dyslexia is inherited, but it is basically a quantitative trait, has multiple attributes. These are quantitative traits, and they exist on a normal continuum of development. I make parents mad when I tell them that the attributes of dyslexia are a variational normal development, because we don't have evidence for qualitative cut points or anything that would actually tell us that this person belongs in the dyslexia category and this person doesn't. And so to a certain extent, those are somewhat arbitrary determinations, and it's one reason that we shouldn't be using cut points and formula and things of that sort to identify kids with dyslexia, because there's a whole learning context that needs to be taken into content. Now, I can give you a really good example of how we breed in traits that may not be particularly adaptive. I mean, what causes dyslexia? Well, the answer is education, because if we didn't expect kids to read and write, we wouldn't be concerned about dyslexia. And so for many centuries, we've bred in the genes, that are related to dyslexia. And sometimes they're adaptive. I mean, take attention deficit disorder, for example. Attention deficit disorder is a complex, multi-phenotypic disorder. It's inherited. The heritability is polygenetic, multiple genetic factors that combine, but it's also dimensional. The attributes are dimensional. Impulsivity, hyperactivity, inattention, they're normal continuum. We have no cut points that tell us on these continuum, when inattention is a category. We might know when it's a problem. I mean, you should have ridden with the kid that I was on the airplane with yesterday. But we bred in those genes. I mean, we're responsible. I mean, they were adaptive. I mean, if you're in medieval times and you're storming castles, right? Who do you want at the front of the line, right? Do you want somebody who's reflective and meditative, or do you want somebody who's impulsive and doesn't think before they act, right? You want somebody who will charge right up those walls. And the survivors basically have bred in, these genes for impulsivity, poor judgment, and things like that. Now, because we have a compulsory education, we actually expect kids to sit still and learn. ADHD is a problem. If we didn't have that, these would not be problems. But it's not a medical model, and it doesn't fit a particular medical model that's categorical, because it fits medical models that are like obesity or hypertension, which are also represented by attributes that are normally distributed in the population. Now, if you're fat, raise your hand. Some of you aren't sure, right? Because the thresholds are somewhat arbitrary, right? And actually, they change every 10 years. Because our society on the whole is getting larger. You know, people are bigger now than they were 100 years ago. They're taller, larger, but height and weight are normally distributed. So why does your physician take your blood pressure every time you go and see him or her? Well, it's because blood pressure assessments are extremely unreliable. It's not like a WISC or Woodcock-Johnson, you know, an achievement test, which are highly reliable. Seriously. These are highly reliable tests. Blood pressure tests are unreliable. You know, if you go in and you see a white coat, you know, your blood pressure goes up. If you go to the dentist, your blood pressure goes up. So they take your blood pressure every time so they can get a baseline, right? And so as you get older, like me, and your blood pressure on average starts growing up, because I have multiple assessments of it. You know, you can look at my medical record and you see that it's going up. At what point does the physician say, you know, I'm really worried about your blood pressure? And what are they going to do? Is he going to send me to, you know, for a heart test and, you know, put me in the hospital to treat my elevated blood pressure? No. The first thing that the physician is going to do is he say, we're going to watch this, right? And then if it keeps creeping up, he or she is going to say, I'm a little concerned about this. You need to exercise more, watch your diet, and we'll see how it goes. I go back and it's still going up. He gives me a prescription, right? I go in and, you know, the veins on my skull are, you know, pulsing, and he takes my blood pressure and he says, oh my God, you've got malignant hypertension. You're going to the ICU, right? Tier 1, Tier 2, Tier 3, right? And sometimes I might go in and all of a sudden I have malignant blood pressure, and it's the first time he's seen me or seen my blood pressure like this, and I'm headed to the hospital, right? Because it's so severe. But in general, that's how we treat dimensional disorders. We screen for them. We collect multiple baselines. We look at your progress. We start adjusting treatment depending on where you are on the continuum, and then we hope for the best. And if you don't progress as we want, then you might have a disability. That's really how to think about dyslexia. That's how you think about dimensional kinds of disorders, and that's essentially how you should think about treating them. And they really are unexpected, because we can teach most kids to read. They become unexpected, and they become problems like dyslexia when they persist, or the child is basically intractable to instruction. So how we think about unexpected underachievement really depends on the type of model that you use. For 100 years, we thought about learning disabilities, including dyslexia, from what I would characterize as a neurological model, where we look for special signs of neurologic dysfunction, because if we could figure out what was wrong with the brain, we could fix it, and we put people in the right intervention. So when I was a graduate student, I used to go out to schools in Winnebago, and I'd bring kids out for 2 hours of testing, and I'd do tests of right-left discrimination, and I'd stimulate their fingers to see if they had a finger agnosia, because those are all parietal lobe signs, and we were pretty sure that whatever problem it was that people with dyslexia had, they were manifested in the parietal lobe, and we were giving parietal lobe tests. That intervention, that model does not work. That gave us concepts like MBD. It led to things like perceptual motor training. I mean, what am I going to do if I find somebody with a finger agnosia deficit? Am I going to teach them finger recognition skills? It doesn't help you read very well, although we still do things, you know, like that. We put kids in front of computer games and have them practice, and somehow that's going to improve their working memory, and that's going to make them read better. Well, it doesn't work, because it doesn't involve reading. So then we have had about 40 years of cognitive discrepancy models. The IQ achievement discrepancy model stands out. There I was doing my neuropsychological evaluations, writing 12-page reports that were 11 and a half pages of test scores and then a half a page of recommendations like put this child in special education. And so I found out that those reports were useless. I actually went out to school meetings and things like that to find out why my reports were useless, and I learned about this IQ achievement discrepancy thing. This is literally 1980. You had to have a 16-point discrepancy between IQ and achievement, and I hadn't even done IQ tests because I'd done all these neuropsychological tests. So I thought that was really interesting. I decided that I would start studying it. I made tenure by studying IQ achievement discrepancy and demonstrated that it lacked validity. And more recently, we have these models that are called processing strengths and weaknesses, where we're supposed to do extensive cognitive testing of kids to figure out who has a specific learning disability and who is a slow learner, because that's going to inform us about treatment, because we're going to get working memory profiles and things of that sort. And those models don't work either. Cognitive discrepancy models don't work. Cognitive skills are very important, but identification on the basis of the presence or absence of a cognitive discrepancy model does not give you a valid classification. So now we're moving into models that are based on instructional discrepancies. You can think about just low achievement, which would be an age-based discrepancy. But if you move into multiple, MTSS or to RTI approaches to identification, what you're then talking about is instructional response. And the idea that instructional response is what makes achievement unexpected. Intractability, persistence. In my research, those are the kids that I'm studying. I want to find kids who are intractable, who have not responded to intervention. I want to know what their brain is like, what their genes are like, and I want to know what I can do to help them learn. And that's very different from what I was doing 15 years ago. But that's how I define dyslexia. It is a problem with basic reading skills, word reading accuracy and spelling, where the child does not respond to intervention that doesn't work with most kids. I diagnose after they've been taught. So it's treat and test, not test and treat. So we know that single word decoding problems are associated with problems segmenting words and syllables into segments, into phonemes. Phonemes are the smallest part of a word that is meaningful, but phonological awareness has multiple causes, like in Bruce Pennington's multiple deficit model. I didn't know you were coming. But it's called the alphabetic principle. Print represents speech through the alphabet or some other visual symbol. These are not arbitrary relations. They have statistical properties. Words have sounds. They can be made into morphemes, the endings of words. But they have internal units, and these internal units have to be related to what the word looks like. Kids do this by making explicit what is inherently an implicit understanding of the fact that words have internal structures that are linked to sounds. And understanding the sound-based structure of speech is what people mean by phonological awareness. Phonological awareness is not a perceptual problem, but if you have perceptual problems, it may cause a phonological awareness problem. Phonological awareness is an overarching understanding of the nature of language that a child has to make explicit in order to phonologically represent the words that they see. And that's the bridge between written language and spoken language. It's through the sound structure of language. But we have to remember that word reading also involves unlocking language from vision. That when words are arranged, they're not arranged arbitrarily. They have statistical properties in terms of the order. The brain becomes very good at representing the probability that a letter string is going to represent a particular word based on the statistical properties of the letter and also based on the visual properties of the stimulus, the word as a visual stimulus. So with repeated exposures, you program a system that becomes the orthographic processing system in the brain. And so we have a phonological processing system, which is sublexical, and we have an orthographic system, which is lexical, deals with whole words, and goes immediately to meaning. And that's what most of you are doing today, is using that orthographic system, because you can look at these words and you know immediately what they are. You don't have to think about what they sound like. that you're going immediately into a sight word repertoire to the meaning of the word. And if I read the slides, it would be the same sort of meaning. So we'll talk about those two systems in a minute. Like I said, dyslexia occurs as part of a natural, unbroken continuum of reading ability. But what's important is that what causes good reading also causes poor reading. There's only one theory. We don't have a theory of dyslexia and proficient reading. We have a theory of reading that is developmental and explains reading proficiency and problems. But it doesn't help us get to the prevalence issue. You read a lot that 1 in 5 kids has dyslexia. Well, that's a little bit of an exaggeration. And I was part of the study that reported the 17.4% of kids that you saw. So let me tell you how you get to 1 in 5. And I'm not in any sense saying that dyslexia is not a significant public health problem. It is absolutely that. But it's probably not 1 in 5 children, depending on how you define it. So in the study that we did, we took a low achievement definition and defined dyslexia as anybody that was reading below the 25th percentile, had an IQ above a threshold, or they could have a 1.5 standard error regression-based definition relative to IQ. So if they read above the 25th percentile, but their IQ was substantially above, and it would have to be substantially above, we're talking about kids that have IQs of like 130 and reading accuracy scores of 95, for example. I mean, they're huge discrepancies. That alone should give you 25% of kids, because it's a normal continuum, and then about 8% of kids in this population-based sample were above the lower achievement threshold, so that's 33%. So the question that you should be asking is, why isn't it 33% instead of 17.4%? Because the prevalence depends on where you put the cut point, right? Well, the answer is that the population-based sample that this was based on had an average reading, an average IQ score of about 110. So the whole distribution is shifted to the right. And so, in fact, there are fewer people in the lower end of the distribution. That's why you only get 17.4%. Most estimates are 3 to 7%. There's a beautiful review of the prevalence issue in the article in The Lancet that Bruce Pennington and Robin Peterson wrote. A lot of these prevalence estimates assume effective intervention, exclusions, no comorbidity, but the thresholds are always arbitrary in the sense that there aren't really categories, and you need multiple criteria to decide when somebody is dyslexic. There is a beautiful meta-analysis by Maggie Snowling, published in 2005, that looked at genetically sensitive designs, meaning that they looked at families in which one of the adults or another child had dyslexia, and they combined across a bunch of different studies. And you can sort of get a sense both about family risk, but also about what happens with these prevalence estimates. So if you had a family member that was affected, and you looked at the 10th percentile and you set that as a cutoff, 34% of those family members met criteria for dyslexia. They read below the 10th percentile, right? Not 10%, but 34%. If you raise the threshold, and people use all kinds of thresholds all the way up to the 30th percentile, it was over half, 53%. And the average across all these studies was 45% in people with a positive family history. If the family history was negative, and you put it below the 10th percentile, the prevalence was 11%, right? Right at, where you put the cut point. And if it was above the 10th percentile, it was 16%, and the average was something like 18 or 19%. So it just lines up perfectly with the normal curve. You don't need to talk about the prevalence of dyslexia to make it an important problem, because it is a very important problem. It is best identified through domain-specific assessments of reading and reading-related skills, particularly reading achievement and instructional response, but your assessments need to be comprehensive because lots of kids have math problems, written expression problems, and ADHD. We'll talk about that in a minute. I don't think IQ tests are very helpful for people with dyslexia. And in particular, they should not be used as aptitude tests. We should get rid of concepts like low achievement. IQ is not a good predictor of instructional response. Discrepancy definitions are not effective, and the same thing is true for so-called PSW models, which I hope you're not being bothered by in your state. To identify dyslexia, we need to look at word recognition, both real words and pseudo words. See if the child can sound the words out. The cognitive correlates or phonological processing. That includes phonological awareness, rapid naming of letters and digits, and verbal short-term memory. But the phonological processing skills are really precursors. They're most important when you're screening. Whether you need them and need to administer them routinely after second grade is unclear. And why I'm bothered by that is I'm now seeing kids in Texas through our dyslexia law where you have to have a word reading, spelling, or writing problem and evidence of phonological awareness problems to qualify for dyslexia services. And I'm seeing kids not getting qualified because they don't meet criteria on the phonological awareness test. And it's measurement error. On average, a person who can't read words in the second or third grade is going to have a problem with phonological awareness, rapid naming. Rapid naming will vary more. Phonological awareness problem is more reliable, and working memory, on average. And if they don't, it's usually measurement error. So the question that I have is, if you see the child can't read words at a certain pre-specified level needed for proficiency, why worry so much about the label? Let's get the kid in an intervention, because that's what's really needed. And it's important to identify this early because kids do not outgrow dyslexia. Over 70% of kids that were identified in dyslexia in grade 3 remain dyslexic as adults. Without adequate intervention, dyslexia is a chronic, lifelong disorder. This is from the Connecticut Longitudinal Project, and this is what it looks like. This is basically growth to a plateau. These are kids were identified here at age 8 into third grade. They got tests of reading every year. I've graphed their growth in reading here. These are raw scores, so you can see the true shape of growth. They're not age-adjusted scores. One of these groups is IQ achievement discrepant. The other is low achieving. You'll notice that there's not a difference, quite a difference in reading between the two groups. These kids, even though they differ by 16 points in IQ, this is a typically achieving group. What you see is growth to a plateau, right? There is no catching up. This is a developmental deficit, not a lag. Children with dyslexia have problems outside phonology. They have comorbidity. That means they have more than one problem. They might have problems with other academics. They might have ADHD. They might have oral language problems. A treatment plan requires that you understand all these sources of comorbidity. And word recognition is not the only type of reading disability. Now, this brings up the question of specificity. I mean, why do we talk about dyslexia as a specific reading disability? Well, it is real, and the IDA consensus definition is narrow. My colleagues, Julian Elliott and Elena Gregorenko, characterized the IDA definition as narrow, and they characterized me as a proponent of a narrow definition. I don't have any problem with that because I can measure it. I know that if I find a person that has difficulty reading and spelling in words in isolation, we may as well call them dyslexia because they're all going to look the same. But it's often part of a very complex presentation, and one of the concepts that's been introduced is the idea of generalist genes. There are some genes that are very specific to reading and spelling and math, but there are others that seem to be broadly involved in multiple learning disabilities and even in ADHD. But ADHD is common. It's anywhere from 30 to 70% of kids that are identified with dyslexia. If you have both dyslexia and ADHD and you don't treat both parts aggressively, you're missing out on an important component of treatment. My colleague Carolyn Denton just finished a clinical trial where she took kids that have both dyslexia and ADHD and she gave them a very intense reading intervention or just medication or both. And what she found is that when she looked at decoding outcomes, The group that got the intervention did better than the group that only got meds. If you looked at behavior, the group that got meds did better with behavior than the group that didn't get meds. But when she looked at fluency and comprehension, which are top-down, frontal striatal, they're in the front part of the brain. That's where stimulants work. When she looked at fluency and comprehension gains, the kids that got both interventions, they got both medication and the reading intervention, did better on fluency and comprehension than the kids that just got one alone. And obviously, treating ADHD is more than just medication, but it needs to be identified and part of a treatment plan. Lots of kids that don't read well have anxiety. I have a colleague who's actually introducing anxiety interventions into our reading groups now to see if that makes things better. Written expression and reading comprehension are almost always impaired. But what's important is that this relationship between phonological processing and decoding shines through the glare of complexity. It is always there in somebody that has a comorbid presentation. We know a lot about what causes dyslexia. I'm going to talk about the brain. I'm going to talk some about heredity. I'm going to talk some about instruction. I'm just going to stipulate that being economically disadvantaged makes you at risk for word-level reading disabilities. For reasons, if you grow up and you don't have adequate exposure to language, you don't have books in the home, things of that sort, you may well develop a phonological awareness problem, and it's not different in relation to SES than the kind of problem that somebody that's at average socioeconomic status would develop. So when we talk about reading and dyslexia, the neuroscience of it is very important. One of the most important things to understand is that learning to read is not a natural process. And it's not constructed just by virtue of simple exposure to language or to words. If reading was as natural as learning to talk, what we would do is get rid of school buses, buy pickup trucks, and drive kids up and down the freeway to expose them to environmental print, because that would be enough to engage the brain in reading. And yet we have illiteracy in a society where literacy is in high demand. That doesn't work. The reason is that language is an evolutionarily, biologically based skill. You don't teach kids to talk. You enhance their ability to talk. You don't teach kids to walk, but you can enhance their ability to walk. And these are skills that follow a natural biological progression. You gibber, you jabber, you say one word, two words, you put sentences together. There's nothing evolutionary about reading. What we have to do when we learn to read is we have to build a neural network onto the network that already exists for language and for visual processing, because we have to deal with the print as well. And that is not a natural process. The most critical thing in building this is to help the brain learn to phonologically represent words and then give it enough exposure to words so that the brain can become a rapid orthographic processor. So good reading instruction, explicitly teaching kids about the relation of sounds and print in the context of a comprehensive program that focuses on automaticity and fluency and comprehension strategies, is always brain-based and is always involved in the development of reading proficiency and the lack of proficiency in kids with dyslexia. When you learn to read, the brain reorganizes. You rewrite the organization of the brain. And how this reorganization occurs varies depending on the structure and the transparency of the language. So it is much harder to do in a language like English, where the relation of what words look like and what words sound like is rough. It's not very transparent. It's easier to do in Finnish, where the relation is very automatic and words are very regular. So in Finland, dyslexia is not really identified by accuracy. It's defined by how fast you can read a list of words. It's a timed measure. But the kids know what the words are, they just can't do it with automaticity. And it always has a phonological basis. we have strong understanding of the neural systems in the brain that are related to reading. They are malleable, and when we teach kids to read, which teachers do all the time, they're mostly normalizing, meaning that we don't go out and develop a dyslexia brain in order to learn to read. What we do instead is we normalize the neural system. We introduce the neural system into the brain of a person with dyslexia when they become proficient and they move away from when they become proficient. The field does not think about the idea that there are bad genes that make bad brains that cause dyslexia. That's an old idea. That's the neurological model. You know, the parent had a dyslexia gene. They passed it on to their child. That dyslexia gene gave the child a bad brain. That child can't learn to read. Rather, what we think about is the idea of genes that make brains at risk. The penetrance is variable, has a lot to do with the environment, and the risk is modified by the environment. But it's a synergy, an interaction of genes and environment. And there are no simple biological tests for dyslexia or learning disabilities, but biology is not destiny. When I tell you that learning disability, that the attributes of dyslexia are inherited and so on, compare it to what I'm going to show you about the malleability. So you can understand what happens at the brain if you understand a little bit about what's called dual route theory. I've already alluded to this. And that's the idea that when we read, there are two routes in the brain that are involved. There's a ventral system that's called ventral because it's sort of in the bottom of the brain. I'll show you a picture of it in a minute. It's a lexical system where you go directly from the word form to pronunciation, and you look up the word in like a middle dictionary of sight words. And then there's a dorsal system that goes up into the language areas of the brain. It is sublexical. It deals with phonological representations, and it's based on the identification of the parts of a word. And they operate in parallel. You're using both these systems if you look at the text up here. And the degree to which you rely on these systems depends to a certain extent on the degree to which you're familiar with the words that you see and sort of the demands of the words, you know, the endings, the pronunciation, things of that sort. So this is sort of a schemata that I took off the web that shows you the ventral system, which is here. Notice that here's the visual cortex here at the back of the brain. This is where all visual information goes. And so when you read words, just like when you look at faces, there's a ventral system here. But if you need to phonologically represent, we have the word, there's a dorsal system here that goes up into the posterior parietal lobe and into the temporal lobes. This is more occipital and into the posterior temporal lobe here. So these are two different systems. An easy way to think about this, which is not really precise, is that when you start to learn to read, and this is true for any child, you have to really rely on this dorsal system because this is the one that lets you phonologically represent words. But as soon as you're able to understand what print represents, so that when you look at it, and it's not just a bunch of things, you know, first you can identify the letters, then you start seeing letter patterns, then they eventually turn into two-dimensional representations in your visual field. You develop a sense of something being a word, not necessarily what it means, but that dorsal is a word. You look at it, and it exists just like this three-dimensional hand. Some people talk about acquired disorders of reading as visual agnosias for words because the person loses their sense of what a word is. As you become proficient, this ventral stream becomes very important because with repeated exposures, it becomes very quick and very automatic in terms of organizing itself as a rapid visual processor of orthographic patterns. And so here's a really nice schema from Stan DeHaan, who's a neuroscientist. And he talks about reading as unlocking vision for language, as opposed to being parasitic on language. And you can see these two systems here. You get visual input here into the occipital cortex. This is that ventral route here. This is the fusiform gyrus. which is called a visual form area, and it represents the brain's letterbox. This is a fascinating structure. What it does is very important for things like object recognition, face recognition. If you take somebody who is illiterate and you teach them to read, which means they become able to phonologically represent words first, and then they start dealing with the patterns, this system literally reorganizes in a very short pattern of time to become specialized for words and not just for spaces. In somebody who's illiterate, faces are bilaterally processed. When they become literate, the left hemisphere capacity for facial processing moves over to the right. The right hemisphere fusiform becomes very specialized for face processing, and this structure turns into a word processor. In young kids, when they begin to learn to read, if you image this area of the brain, you can and do functional imaging studies. You can actually see patterns of activation increase very rapidly as this system gets organized to be a rapid visual processor. But it is very much an experiential sort of problem because you have to phonologically represent the words, and then you need a lot of exposure to make it work. And so people do functional and structural neuroimaging studies. This is a MRI where we could do structural imaging studies. We could also flash stimuli, have people read and take slices so fast that we can image blood flow, changes in blood flow in the brain. How many people have had an MRI? Did you know that we can image kids as young as 3 with these machines and actually do functional imaging with kids who are at risk for reading problems? It's very interesting. This is called magnetic source imaging. It's an imaging modality that my group has worked with, and it's a neurophysiological technique because what this helmet does, is it records magnetic signals that the electrical currents in your brain generate as different neuronal networks fire, and we can use that to identify not only where but also when in the brain different activity is taking place. This has just revolutionized our understanding of what happens to the brain in reading and in dyslexia. And so here, these are, I deliberately show old studies when I do this because I want to emphasize how long we've known these things. These are just 2 third graders, one of the first studies that we did. And you can see in this third grader who's a proficient reader, activation of this ventral route. Here's activation of the dorsal route. And then if I want the person to pronounce the words or deal with grammar or something of that sort, I'm going to get activation up here in the inferior frontal gyrus. And people refer to this as a triangle network. And you can see very nice patterns of activation here in response to words or letters or things of that sort. Now this child is a third grader who has dyslexia. You don't have to be a neuroscientist. Do you see a neural network in the left hemisphere? It's not there. What you're getting instead is activation of the same areas in the right hemisphere, but what's the problem? Well, the right hemisphere is not very good at language. I don't know exactly why we get right hemisphere activation. I think it's because the person may be trying to deal with words as a visual stimulus because the word doesn't make sense as a word to them, or it's a very novel task because they don't read very much. But we don't get, we get this very lateralized sort of pattern in people with dyslexia. And you can actually see it on a case-by-case basis with this particular method. The question is, does it change? Is it permanent? And if it changes, are the changes normalizing or are they compensatory? So very early on, we took 8 kids that had very severe dyslexia. We gave them 8 weeks of a very intense phonologically based intervention over the summer. They got 2 hours a day, up to 80 hours of instruction, focused very much on helping them read words. That's what the goal was. After 8 weeks, all 8 kids who ranged in basic reading skills from the 1st to the 16th percentile were reading words from the 38th to the 70th percentile. It doesn't work with everybody. This is one of the first studies that we did, but it works with about 70% of kids above 3rd grade that we do this with, if it's intense enough. It's the intensity that's hard to get. And then we image the kids before and after the intervention. These are just two cases. Notice that there's very little evidence of the neural network in this kid before the intervention started. 8 weeks later, what do we get? Enormous activation of the dorsal system. That's important, and actually a reduction in right hemisphere activation. Same thing was true in all 8 kids. They all showed normalizing changes. In general, there are now over 20 studies like this. They generally show normalizing changes in the dorsal and ventral systems in people identified with dyslexia who respond to the intervention. You don't see these changes if you don't respond to the intervention, although you will see evidence of the neural system starting to develop. But these kids needed a very intense intervention. It is not that they did not have dyslexia. There's no question about what their problem was. But they responded to a very intense Tier 3 intervention. They were not fluent. And fluency and automaticity is the big issue with these kids. We know a lot about genetic factors in reading disability. We know that reading, math, and writing are heritable traits, but the contribution of individual genes is small. There's little evidence for genes that are specific to poor reading, like dyslexia genes, but there are candidate genes that people are studying very extensively. There are 9 of them. They just don't account for much of the variance, and the most interesting information comes from behavioral genetic, quantitative genetic studies, which were actually developed in Boulder, just down the street, where we know that 50 to 70% of the variability in reading outcomes is explained by genetic factors. The other 30 to 50% is explained by shared and unshared environmental factors. But what's really important is that individual differences in reading are accounted more by genetic factors as the child gets older, and there's this huge homogenizing effect of schooling on kids when they enter school, so that you see the genetic correlation actually increasing with age. Again, this doesn't mean that these aren't malleable systems. It does mean that it takes a lot of intensity if you wait to work with them. And so we underestimate the role of instructional factors. The skills that prevent dyslexia and poor reading can be taught, but they have to be taught early. Some children who are placed in special education are instructional casualties because they did not get the instruction that they needed. This makes some people mad, but it's true. If you effectively teach reading, you will reduce the number of kids who end up in special education. That was shown repeatedly in Reading First studies. And in my opinion, dyslexia should not be identified in the absence of adequate reading instruction and should be defined by persistence or intractability. What represents effective intervention? Well, the most important word is explicit. Reading educators get all hung up on words like systematic or scope and sequence or manuals, and they want to script things. But what really matters is that the instruction itself is explicit enough so that the teacher intentionally shows and models what it is that the child must learn. It is not discovery learning. And then the approach needs to be explicit. It is not enough to just go in, unless you've got a child who hasn't responded and you just have to get them to decode. Then you want to go after decoding with a sledgehammer, like we did in that 8-week intervention. But typically, particularly at Tier 1 and Tier 2, classroom and supplemental instruction, you want to make sure that you have components that address comprehension and fluency, and they're explicit. So you want kids reading scaffolded text at their instructional level because they have to practice, because if they don't get the exposure, you won't program that ventral system. And then for kids that have dyslexia, if you don't help them link comprehension with what it is that they're doing with reading, they won't get it. They often have self-regulation difficulties. They don't necessarily generalize. You need comprehensive reading programs, particularly at Tier 1. You have to prevent word recognition problems because remediation is difficult, requires considerable intensity, particularly to develop automaticity. But older students and adults can be taught word recognition if the approach is sufficiently intense, but fluency is more difficult. There is no specificity of dyslexia interventions. And what I mean by that is that when people say that only certain interventions work with kids that have dyslexia, the key issue is explicitness. There are absolutely programs that don't work, but you have to have an explicit alphabetic component as part of that program. And there are lots of ways to teach that explicit alphabetic component. You can teach it as letter sound rules, phoneme graphing, correspondences. You can use pictures. You can do it in the context of reading and writing if it's explicit enough. Stay away from words like systematic. Focus on explicit, because that's the important term. The problem is that our traditional service delivery models are ineffective. If we wait for kids to fail and then we refer them and put them in remediation classes, we are not going to close the gap. This is from a study that was done many years ago, and it looked at changes in reading skills in kids who were placed in special education in grades 3, 4, 5, and 6. And what they found is that kids that were placed in special education in grade 3 showed growth in reading scores of 0.04 standard deviations per year. Now, these are standard scores. This means that they've been adjusted for the age of the child. And what this means is that if you started out and you're at the second percentile in third grade, 4 years of special education would move you to the third percentile. Now, what's important about these graphs is that these are flat lines, because without the support, and I'll show you this later, the children would have continued to fall behind, because what you've done is you basically have normalized their growth rate, or they would have fallen behind, but what you haven't been able to do is to accelerate it, and we want to close the gap. Now, this is one of the 8-week interventions that I talked about earlier. This is from a study that Joe Torgerson did in 2001. He took kids that were identified in special education. They all read below the 5th percentile in basic reading skills. They were essentially non-readers, 3rd, 4th, and 5th graders. He gave them the 8-week summer intervention that we talked about. This is where we got the idea of doing it with the imaging study. He had their reading score on them. It's not the same score that he used for identification. It's a little bit higher. But you can see here the same sort of phenomenon. They're in special education for 18 months. They have flat lines. These are age-adjusted scores. If I showed you raw scores, they would certainly be accelerating, but not at the same level as kids who are typically developing. He had 2 different interventions. One was the Linda Mood Bell phoneme sequencing program, and the other was an approach that he called embedded phonics, and I'll show you the differences in a minute. What's important is that in this 8-week intervention, he got significant progress. The kids maintained their gains for 2 years. We're always shooting to get kids up into the average range, which we would define as the 25th or the 30th percentile. Notice that there's no difference in these 2 programs, and yet they're very different. So the Linda Mood Bell program is a heavy-duty decoding program. It teaches phoneme awareness, phonemic decoding, some sight word instruction, but it really focuses on using articulation and a multi-sensory kind of approach, so that some sounds are lippers, some are puffers. They show you pictures of it. He compared that with this embedded phonics program where there's 20% was an explicit, remember that word, explicit alphabetic component. He taught phonics explicitly, but he had 30% sight word instruction and 50% reading and writing connected text. No difference in the 2 programs, both explicit. Problem was that I only showed you accuracy. If I showed you comprehension, I keep meaning to change that slide, but I forget. The comprehension slides look just like the accuracy slide, so don't ever tell people that learning to read words doesn't help you understand what you read. It's true, it does. It doesn't make you automatic, and you don't become automatic and fluent because reading rate was virtually unaffected by these interventions. Now, why is that? Well, he had kids read material that was at grade level, and then he had kids read material that was at instructional level. If they read instructional level material, the fluency difference went away. When they read grade level material, there were so many words that they had to stop and sound out that not only did they slow down, they couldn't remember what they were reading while they were reading it, because that's what happens if you don't have automatic decoding. So basically, the number of words that these kids couldn't read by sight was not sufficient for them to read grade level text. And this is why you can't close the gap if you wait 3 to 5 years to help a kid access print. What's happening at the level of the brain is that you're not giving the child enough explicit print exposure, and it's not just exposure that works, it's explicit print exposure in the context of instruction, so that the child can begin to read independently and get enough reading experience to program that ventral area and develop the fusiform area. I mean, we understand what happens, and this is why remediation is so much more difficult than early intervention. So some questions. I mean, why do we take young students who are struggling out of the classroom environment, particularly in elementary school, when they need to spend more time on task? If you study what happens in traditional special education programs with resource rooms, extra lessons, dyslexia classes and things like that, what tends to happen is the child actually gets less reading instruction than they would have if they stayed in the general education classroom. And what you really want to do is to supplement that instruction. You want the child to get as much general education instruction, good general education instruction as possible, and then add to it. Increase time on task. So why not use additional instructional opportunities to supplement and even differentiate even more? How can you know who has a learning disability in the absence of adequate opportunity to learn? So why not integrate classroom and remedial instruction and use intervention response to determine the level of intensity and the degree of differentiation that's needed? Some people say that all that happens with an MTSS system is that all you're doing is giving kids more time, and that's not enough. That is completely false. What you're also doing is you're providing increasing differentiation of instruction. And so it's more time on task, more comprehensiveness, and more differentiation. And if you're not helping teachers differentiate, identify the child's strengths and weaknesses in reading so they know where to target instruction, that's not going to be an effective multi-tiered model. Now, everybody has seen these kinds of models where we talk about general education classroom, a secondary intervention, and then a tertiary intervention. I've been at this for a long time. I have a very simple message for everybody. If all you do is you go into kindergarten, grade 1, and grade 2, you introduce screening, you monitor progress, you provide professional development for your kindergarten, grade 1, and grade 2 teachers so that they have access to a comprehensive, explicit program, and they understand how to use screening and progress monitoring data to help them differentiate in the classroom. And then you introduce 30 to 45 minutes of supplemental instruction. You will take a huge whack on kids who eventually have dyslexia or other kinds of reading disabilities. If that's all you do, 4 things: screen, monitor progress, enhance core instruction, introduce supplemental instruction in the early grades. I mean, the mistake that some of us have made that have been at this for a long time is we made it too complicated. We showed you all these tiers. We talked about all these things that you have to do. We should have been much more focused on that. If you get that done in a school, then you can move on, into other areas and things of that sort. You should do the same thing for behavior. But you can do reading and behavior in the early grades, have a huge whack on kids that eventually get identified with disabilities. What should the content be? Nothing new here. The National Reading Panel report is not out of date. They're consensus documents. They say that instruction can prevent reading difficulties. They emphasize the integration of, and integration is the key word, explicit alphabetic instruction, which involves word recognition, reading for meaning, which is comprehension, and that means both oral language and strategic instruction, and active engagement, meaning that the kid is actively engaged, usually in some sort of assisted learning, assisted adult fluency learning to develop automaticity. And there are lots of ways to do that. But it's an integrated, comprehensive approach. The very best research on effective Tier 1 instruction is being done by Carol Connor, who's at UC Davis now. She keeps moving around. But she has done 7 randomized trials now looking at ways of enhancing classroom reading instruction. And what she does is she takes kids, she gives them very short assessments. She figures out their level of decoding ability, their level of vocabulary, and their level of comprehension skills. She puts that into an algorithm. And what the algorithm does, this little computer program, is it tells the teacher how much time each child needs to spend on code-based instruction, how much time they need to spend on meaning-based instruction. It spits out lesson plans, and then it also spits out groups, because differentiated instruction in the classroom is about forming and unforming instructional groups. And it tells you that these kids belong together, these kids belong together. And she finds that providing more code-focused instruction for students that are weak in word reading and more meaning-focused instruction to students that are weak in vocabulary and comprehension leads to substantially higher classroom-level gains compared to controls, and that this accumulates if you do this in grades 1 through 3. It's very powerful research. If somebody asks me what should I be looking at if I want to really understand the best core reading research, that's it. Reading integration has to be integrated from kindergarten to grade 12. If a critical component is missing, students who are at risk will not develop that component. Success in reading are the opposite sides of the same coin. It's the same theory, not two theories. We don't have a separate dyslexia theory. Instruction is the key, but not all students respond to instruction, and we have to have programs for kids who just don't learn. If you think about it from a special education perspective, this is the difference in the kinds of models that we're talking about. This is a traditional model. Somebody gets referred, the teacher says, test this kid. I found one. Can't work with this kid. We know that if we do that, more boys and girls are going to get referred. Boys are going to be over-identified. Girls are going to be under-identified. A comprehensive assessment is done. That's usually a set of tests done by a school psychologist. Some kids are eligible. Some kids are not eligible. What do we do with the kids that are not eligible? They go back to the classroom, and we have names for them like slow learners, right? They get a treatment. What's the treatment? It's the IEP, right, which only has to specify goals. It doesn't specify methodology. How often is that treatment plan modified? Is it every 3 years when the comprehensive evaluation is redone? Is it every year when we reset the IEP goals? Does that really mean that a child could stay in the classroom stay under the protection of special education and make no progress for a full year? Happens all the time, unfortunately. That's not a very special model. In an MTSS model, everybody's screened. Everybody's progress is monitored. You immediately get intervention in the classroom because everybody knows that this kid is at risk, and that's the concept that we use. It's just risk. It's a malleable kind of concept. We don't diagnose dyslexia in kindergartners. We simply talk about who's at risk. If you don't respond to classroom instruction, you should get some kind of supplemental instruction. If you go to several episodes of some sort of supplemental instruction and nothing is working, you may need the protection of special education. You go because there's data that says that you're not making adequate progress. You get a comprehensive evaluation because a comprehensive evaluation is required no matter what. But that comprehensive evaluation that's done in an MTSS model is after a different question and should be based on different methodologies. The question is, why hasn't this child responded to intervention that works with most kids? Because the number should be down. And what is it that I need to know about the child in order to plan a more effective intervention? To me, that means that we're going to focus very much, if we're in the reading area, for example, on reading and reading-related skills. I'm always going to look at achievement comprehensively with norm reference tests. I'm going to take the curriculum-based data that's been used as to monitor the child's progress as my assessment of instructional response. I'm going to worry a lot about comorbidity, which you're required to do because of the exclusions. I need to know about English language proficiency and things like that. But my goal is to minimize the amount of testing, because every dollar that I don't spend on testing, I can spend on intervention. I need some testing to make sure I have an appropriate treatment plan and to comply with the requirements of IDEA. Some kids are going to be eligible. Some kids are not going to be eligible. But if they're not eligible, it's going to be because we know that special education is not the right intervention. The kid has not been coming to school. There are problems at home. It's really ADHD, and the child is so distractible that that special education is not, a special education class, a reading program is not what the child really needs. English language proficiency is an issue. Those sorts of determinations. They go into a special education classroom. Their progress continues to get monitored. You look at kids every 10 weeks. What are you going to do if you have a kid in a special education program for 10 weeks and you look at the progress monitoring data and it's flat? What are you going to do? Give them 10 more weeks of the same intervention? Change it. Change it. You got to see growth. And we're always thinking about concepts like who's responding adequately, who's not responding adequately. And if you're not an adequate responder, what you want to do is make sure somebody studies those kids, because we really need to understand about kids who don't respond to intervention. So this is sometimes called a hybrid method or a triangle approach to identification. It was laid out in a summit by the Office of Special Education Programs in 2002. And it simply talks about three criteria. You establish low achievement. You evaluate instructional response, because that tells you that underachievement is unexpected. And you apply the exclusions. This does not mean that dyslexia is not real, that kids with dyslexia don't need specialized kinds of interventions. It simply means that we make decisions about what those interventions are in the context of really strong and solid reading instruction, because we need to know that an explicit alphabetic approach delivered in the classroom and through Tier 2 instruction is not adequate. And that's when a more specialized program might really be needed. But we also need to move away from the idea of formula. The thing that disappointed me the most when IDEA 2004 was addressed, was passed in 2004, is that states immediately started setting up new formula-based criteria so that you had to be below the 5th percentile. Well, those are inaccurate, ineffective ways of identifying people, because if you set a cut point on a normal distribution, and let's just say 10th percentile, well, what's going to happen, because the tests have small amounts of measurement error, they're not like blood pressure assessments. I assess kids at the 10th percentile, say in instructional response, or on a norm reference test or something like that. If I go in and I test a kid again 8 weeks later, I am going to cure dyslexia in 30% of the group, because 30% are going to move from below the 10th percentile to above the 10th percentile. The problem is that it's iatrogenic, because 30% are going to move from above the 10th percentile to below the 10th percentile. And that is inherent when you're talking about problems, when you're talking about normally distributed dimensional disorders. You can fix that if you put in a confidence interval, but what you really want to do is to think more broadly about what the child actually needs. That's why these are team-based decisions. And I like to quote this guy, Ed McMahon, who knew this 20 years ago. He said that even though the psychometric difficulties may never be completely resolved, classification systems should at least be based on a coherent psychology of helping. Hear that? Helping kids. There is no shortage of children who experience problems. Assessments and classifications can be guided by principles of intervention design with expected errors of judgment, meaning that we might screen a kid, we might make a mistake, but we will know it if we have a kid in a sequential monitoring system. We say, oh, that kid had a bad day. They don't need any more assistance. And he talked about a system of recursive and empirical practices. Extensive testing does not increase the accuracy of diagnosis. It should be test and treat, not treat and test, not test and treat. And the most important error, what you want to do is reduce false negative errors. Screen briefly, monitor progress, but make sure that you monitor progress in kids who are at risk and that you don't miss them. You're going to have lots of false positive errors, but the relation between false positives and false negatives, they're statistical. If you want to reduce false negative errors, then you're going to get an increase in false positive errors, and that's why screening should be brief, and that's why we need to monitor progress to correct errors. We know that early intervention is clearly effective. That prevention studies commonly show that 70 to 90% of the at-risk children in the bottom 20% can learn to read in the average range, and that we prevent automaticity problems when we do this. This is another one of Torgerson's slides. This is the study that I showed you before. This is the second study he did like this, where he's getting a little bit better at building automaticity. But these are results from two different studies where he did early intervention, where he gets comparable growth in fluency, in word recognition, and in the red is fluency, because the child had access to print early in their development. And it persists. Some people say that early intervention doesn't persist. This is a study by Benita Blockman, who gave second and third graders 1 year of explicit alphabetic instruction as part of a comprehensive reading program. This is the difference between in the pretest scores. You know, they're comparable at pretest. This is after 1 year of intervention. Kids who got the intervention are doing much better than kids who didn't get the intervention. These are second and third graders. The average score is around the 27th percentile, but half the kids are reading in the average range. We saw the gains 1 year after 1 year, and they persisted all the way through high school. This is an effect size of a half a standard deviation. In word recognition, there was an effect size of a quarter of a standard deviation in comprehension. There were clear trends for kids to be more likely to graduate, go to college, but the sample wasn't really large enough. And Benita's main regret is that she only gave these kids 1 year of intervention. She wonders what would have happened if she had kept working with other kids. Now, I'm starting to run out of time, and I have a bunch of studies that I can show you that demonstrate the value of early intervention. And what I'm going to do instead, these are easy to find articles. If you email me, I'll send them to you. I just want to show you a couple of highlights from these studies. So this is a study that we did as a group where we provided a Tier 1 intervention on top of enhanced classroom instruction. District had a reading program. They introduced a basal reading program that had an explicit alphabetic component. We gave kids an additional 40 minutes of instruction 5 days a week for 30 weeks in small groups. One intervention was a very explicit manualized intervention with the scope and sequence, very traditional alphabetic phonics program, but with very explicit automaticity and comprehension components. We literally had people writing stories to build on the phonics elements that we were doing, and also comprehension lessons based on the story. And then we had an intervention that we modeled deliberately to be an intervention that was taught in the context of reading and writing. So it taught explicit instruction in synthetic phonics and in analog phonics, and teachers had to do 1/5 of every lesson, 8 minutes on instruction. It was not incidental. There was no use of the 3 cueing system. They only learned one strategy, which is sounding out words. But it was all done in the context of reading and writing. There was no manual. There was no predetermined scope and sequence. Nobody would call this systematic. Rather, teachers had like a bag of tricks, and they would get together as groups and talk about what to do. They responded to student needs as they observed, and they used level text, not phonetically decodable text. No difference. Notice that enhanced classroom instruction worked for kids who got the pull-out intervention, but it did not work as well as kids who got both pull-out and Tier 2, and that kids are closing the gap relative to typically achieving kids. To me, this is what the brain looked like before the intervention. These kids are at risk here. They're just doing a simple letter sound task. Notice that there's no development of the neural network here. You could actually see this neural network in kids that are at risk. But then we get normalization after a year of instruction in people who respond. At the end of the intervention, we could actually classify kids who are not at risk, who responded. See the development of the neural network is still very much a bilateral pattern in first graders, but you can see it emerging in kids who did not respond here. Fortunately, there were very few kids who did not respond. if you took benchmarks of basic reading skills at the 30th percentile as well as the fluency benchmark, if you just looked at the basic reading benchmark, if you only got enhanced Tier 1 instruction, there were 15 out of 92 kids in the intervention who were not reading at grade level. That is 16% of that group. But because we screened for the bottom 20%, we reduced the number of kids that are at risk at the end of first grade from 20% to 3.2%. If you got the pull-out program, 4% of those kids did not meet the criteria. That's less than 1% of the school population. So just this alone is having a huge impact in the at-risk kids. So then in second grade, and for some kids third grade because they got retained, we introduced the Tier 3 intervention, which is that 2-week, that 8-week, very intense intervention. We did 8 weeks of that intervention. We did 8 weeks of Read Naturally, which is a fluency-based intervention. It does not help kids with decoding, isn't suitable as a Tier 2 intervention by itself. They got phonographics, which is a morphological method. And the thing that I wanted, the average gain in the 16-week intervention was a half a standard deviation, which is the red arrow. This is all the kids that did not respond. And all I want to show you is the enormous variability on what is essentially a normal distribution in who responded, right? So we did this in a rigid way. You got 8 weeks of this, and then you got 8 weeks of this. We didn't try and tailor it, but should we have put these kids over here on the left? Should we have continued them in this intervention here? They're not making progress. These kids actually have very persistent problems. These kids need 12 weeks, not 8 weeks. We should have continued with them. But you can see how you can begin to layer these interventions on. And then look what happens when you do adolescence. I'm going to run through this very quickly. First, we took every kid in grades 6 through 8 who did not pass the state test, which is a reading comprehension measure. That's 1,000 kids. 81% had problems on norm reference. They read below the 20th percentile on norm reference, decoding, and fluency assessments. We thought we were going to do a comprehension intervention. We ended up doing a lot of word work with these kids. We ended up doing the intervention over 3 years because we did it for 1 year, and we had mostly worked with elementary kids, getting big effects. We had almost no statistically significant findings after 1 year of intervention. And we have teachers with 5 to 10 students. We're taking an entire class period. We did this for 35 weeks. You know, think of how many hours this is. Very little change. If we did it for 2 years, we got moderate effects on decoding, fluency, and comprehension. If we did it for 3 years, and what we're doing each year is we're dropping out the kids that respond, so we're only working with the inadequate responders. If we gave them 3 years, we got moderate to large effects on decoding, fluency, and comprehension. But look what's happening. From grades 6 through 8, what's happening is we're getting some acceleration in the treatment group, but not at a desirable level. Some, but not where we want. But look what's happening to the control group that doesn't get any intervention. So, they don't have a flat line. They're showing a decline. They're not actually deteriorating. If we looked at raw scores, they would be accelerating, but the rate of growth is not adequate. And this is how special education or special programs helps kids. It keeps them from plateauing. So I'm going to stop now, and I'm just going to point out that there are different viewpoints. I think that effective intervention has to increase intensity and differentiation, increase time. They should supplement. They shouldn't supplant. They have to teach reading, math, and writing. If they don't teach reading, math, and writing, they're not going to work. There's not going to be any generalization. The longer you wait, the more of a problem it's going to be. Intervention always begins in the general education classroom. We have to assess progress. There are different viewpoints. Pay attention to the evidence. Look at books. People are going to a lot of trouble to write books about this research. I have one. I get 50 cents every time one is sold. Bruce has one. Mark Seidenberg just wrote one that's just outstanding. There are lots of books about what the science actually shows. Pay attention to the evidence. Some believe IQ is essential and discrepancies are inclusionary. They support extensive diagnostic testing and reject instructional response as a criterion. Look at the evidence. Some believe reading proficiency is just a matter of exposing the child and engaging them in literature. Look at the evidence. Some believe that there are special dyslexia-specific interventions. I am not saying that programs that have been commonly identified for children with dyslexia are not effective. They are. I'm just saying that there's a wide range of programs that are effective, and requiring certain types of programs is probably not in the child's best interest. We need flexibility. Or that we can directly change the brain through games. Don't believe what's advertised. Some believe there should be special classes or even charter schools for dyslexia. I personally am not willing to let general education off the accountability hook. Some believe that dyslexia isn't real or that science isn't informative. And there are lots of things that we don't know. We don't know enough about high IQ kids, adults who need accommodations. We don't know enough about assistive technology, accommodations, what to do with inadequate responders. There's a lot of work to do still. But I'll leave you with two thoughts. The first is, who is dyslexic? It is the student who does not respond to quality instruction. They are hard to teach, not unable to learn. It's low achievement and inadequate instructional response. It is preventable with early intervention in many kids. It's heritable, but the neural systems are malleable. And then a thought from one of the people who discovered the alphabetic principle, Alvin Lieberman. He said that we are all born with dyslexia. The difference among us is that some of us are easy to cure and others are not. Thank you very much.